Okay, yeah, so over to Christopher. So Christopher has posted a bit about the blogs on the work with MetaWards and tutorial-driven development. So I asked him to give a bit of a presentation on that. So yeah, everybody knows Chris. Over to you, Christopher. Thank you.
Thank you. And I apologize straight away for being one of these people who kind of fly into a meeting, give a talk, and then at lunchtime will just vanish. That's because this week we've been running something that's called the Data Week. So every day this week we've been teaching researchers, software engineering, machine learning, data analysis. We've been hitting somewhere between 70 to 100 plus researchers a day. And indeed, this afternoon I can't be here because I'm teaching best practices in software engineering with about 117 people signed up. So hopefully that will work. And obviously going to be using MetaWards, which I'm talking about today, as an exemplar to say that, look, we follow best practice and we're not just telling you to do this, we actually use it and it is useful. So the slides for this talk are available at my website that's linked there. And I'm going to focus mostly on talking about tutorial-driven development as we've applied it to MetaWards. But I was going to spend just a little bit at the beginning of the talk talking about what is MetaWards, in case no one's noticed what's been happening in the world in the last few months. So there's been a disease, stuff's happened, the world has changed. And MetaWards was one of the pieces of software which was used way back in February-ish, March-ish now, to provide evidence as to what would be the likely impact on the UK if we just let a disease just rush through the entire population. So these are the emerging evidence links from the government SAGE group. And as you can see, the link highlighted is Leon Danon's link, which is this spatial model of COVID-19 transmission in England. So what made this model different and interesting is it is what is called a meta-population model. So you have every single person represented. So I have a model version of each of you sitting at my computer. And essentially the model basically moves people around the country as they go to work or they do things at home. And then it then lets a disease outbreak spread through, and through your interactions with each other, determines whether or not in a particular electoral ward there will be an infection and you would be infected. And then when you go to work, are you going to infect the people at work, etc., etc. And so by this, it was able to model the spread of the disease through the country. Now, preprint came out in mid-February. It's one of the earliest bits of modeling that showed basically where the UK peak was going to be. It is quite well. So you can see people sort of tweeting about it through the year. So this was predicting way back in February that the Northeast would be doing particularly badly. That is kind of what we've been seeing. As these models were coming out, and as this impact on society of government responding to the predictions of these models, you were finding that there was this big swell from the public to quite rightly have these models published. Because obviously, you know, you can't have government completely change the way that all of us live, saying it's based on evidence, but then not actually share the evidence with all of us so that we know what's going on. And as it says here, fearless leaders in a democracy share the information to gain trust, because trust is absolutely central to all of these decisions. So that was a request in March. You can see here again in the beginning of March, this person saying, look, here is one of these models. You can actually get it, predicting peaks at various times. And the reason they were picking this up on Twitter was because this was one of the few models which was actually published and publicly available from a very early date. So Leon was really good, and what he did was pretty much as soon as he made the paper, he did what we always ask researchers to do, which is please can you put your software on GitHub with some documentation. And this is the original GitHub repo. So I just took a snapshot of that. Basically from when he committed it on the 28th of March. Now he's been kind of honest-ish when he's posted things. So he's not published this with a view of what the public would think when they saw it. So if you're a random member of the public being told, we have used a model and models like this to decide that we're going to completely lock down the country and destroy your livelihood, you probably wouldn't be filled with much confidence that the first initial commit message is working ? Because again, people, when you're writing these codes and running these models, you're not really thinking about how it will be viewed by the public. And again, there's a trust thing that comes from this. So anyway, he published in January. People began playing with it and looking at things through February and through into March. But then there was this growing kind of furore, I think we were all sort of aware of and saw, where essentially when it came to the middle of March, there was this big push that you must publish these codes, you must show these things off. And there were beginning to be attacks on codes on Twitter, and it was getting quite nasty. So basically that's when Leon came to the Bristol RSE group and he said, I've published this, help. What should I now do? How do we now go forwards? And that was on the 23rd of March. Now, he originally approached Chris, because Chris in my group basically does all of the first point of contact, Ask RSE responses. So Chris arranged a meeting with him, and this is Chris's email back, because when we have a meeting, we send an email that kind of summarizes what was discussed and what was agreed. And as you can tell, my group follow my kind of like philosophy that the most important thing we do is reproducibility and testing. So the first thing we tried to say to Leon was like, you probably should add a little bit of testing, integration tests, maybe some unit tests, just so that we can show that what you're doing is reproducible and that people can begin to trust it. And then we were noting from the way you published your code, everything was in a CPP file, but actually you've written things in C. And that's actually because way back in the mists of time, when you originally developed this code 10 years ago, you were using VTK for visualization. And the build system for VTK required all of the files to be called CPP files rather than C files. So this is one of the reasons that when you look at some of these codes, they're C in a C++ file, which is a little bit strange. This is what some of the code looks like. And indeed, actually, if you look on here, just go back to that point, what you're seeing here is effectively this is the code. So you have one CPP file. That CPP file is basically the entire software. And then you have here a main file, and the main file contains all of the parameters for the software. And what you do is you compile the main file against the CPP file and then run the resulting executable. And so their push to reproducibility is that they have a directory called mains, which contains all of the old main files that contain the main functions. But that was fun when we first saw that. So this is the code. The code is basically one big C file and a CPP file named file system. As I said, you change the code by editing hard-coded numbers and then recompiling it. It's all just in one big 3,000 line thing. You switch on and off parts, as you can see here, by using different compile flags to turn on and off the modeling of self-isolation, but that's kind of mixed in. So half ideas that were in the code are kind of there mixed in with some of the newer changes. So some of these things are incompatible with each other and you're not entirely sure what you can do and what you can't do. It's fun. It was a very fun code to go through. Now, as I'm saying it's fun and I'm kind of almost like saying like I'm a bit negative on this code, I should point out that I'm not negative on the code. I actually think this is a good code. And why is this a good code? It's a good code because it worked. So I think in the research software community, we can sometimes be quite negative to researchers who've produced a bit of software on their own and then haven't followed what we call best principles, because we forget that all they're trying to do is write a piece of software that works today. So when Leon wrote this code, it was in a response to modeling the influenza outbreak, and he needed to quickly get numbers which he could basically show to government to deal with influenza. Other codes were written for things like the foot and mouth outbreak, and they needed something which worked today. The issue that we've got is that the research software that people are writing that works today is now being put in production. And indeed, it's now not just being put in production, it's being applied at scale. So anyone who's seen one of my Bridges talk, this is taken from my Bridges talk, and essentially there's nothing at all wrong with the piece of software that's made by a scientist to solve a problem today. It got him across the river, there is no issue. The problem is that we're now trusting these bits of software to get us across other rivers or across massive rivers, and I don't think we should be. The job of research software engineering is to change the software so that you can put it into production and you can apply it at scale. And that's where you need to go from I'm programming something to solve today's problem into I'm engineering something that will be sustainable and can be used by others to solve tomorrow's problems. Now, what is software engineering? Why do we need it? ultimately it comes down to Mike Croucher's law, which I think is a very good law, which is I can be an idiot and I will make mistakes and you are no different. And if we apply that to programmers, when I write code, I make mistakes. My code is buggy, your code is no different. So basically, whenever I write software, it is full of bugs. There is no piece of software that I have ever written which is bug-free. And indeed, pretty much, I create probably 5 bugs a day when I'm writing code, and they're quite hideous, horrible, hard to find bugs. And the difference between a programmer and a software engineer, in my sort of opinion, is this. A programmer is somebody who just writes code. They assume that their code is right because they run it and the graph looks right. And so, hey, the code compiled, the graph looked right. I'm perfect, I don't make mistakes, so the code is right. They have basically no systems or few systems or procedures in place to limit the blast radius of any of their mistakes. So if there's a bug in their code, there is very little in that code to actually detect that bug and then mitigate against it. And indeed, if a bug is found, they have almost no understanding of what the blast radius of that bug was. So, what could it have affected? What could it have changed? In contrast, a software engineer is somebody who understands that they're human and they will make human errors. And that means that they don't just assume their code is correct, they actually put in place procedures and systems that check that their code is correct. They also understand the limitations of those systems and procedures. So they know that they can only show correctness to a particular level. So they understand the limits of correctness of their code. And they're investing the time and effort into those procedures so that if there is a mistake in the software, the blast radius is minimized. So there was a bug here. I thus know that that only affected these results here. I can then reproduce things, do comparative studies, do a regression test, then work out how that affected any other previous results. Now, some may argue that when you're in a crisis, doing all of these procedures and following these rules is too expensive. You just don't have time in a crisis to be able to implement testing, to be able to implement all of these systems. But my argument is that the middle of a crisis is exactly the right time to follow proper procedure. The reason is many of these procedures were developed because of poor human judgment and human error from previous crises, and we need to learn from the mistakes of our past, apply the procedures and the systems that were developed in the past to basically control our behavior now in current crises. So I've posted a couple of links here, and basically the role of process management in handling a crisis. Obviously in the airline industry, everything is about how you actually have procedures that you follow when you're in a time critical crisis. Particularly, your plane is taken off, the pilot, when there is something that happens, the engine blows up or whatever, there is a strict set of procedures that they follow, even though they may only have minutes to make the right decision. And they do this because they know that the normal human behavior will make mistakes, will rush, will do things in a thoughtless way, and will create a worse situation if we don't follow proper procedure. So I was brought onto the project by Chris. He was like, look, there needs to be a lot of stuff that needs to be done to MetaWards so that people can look at it and they can trust it. And we're going to avoid Leon being the subject to a hate campaign. So what I did is I came on and I did a quick review of it. Everything I did is listed in the blog, so I'm not going to go through most of that now. But my main driver was that I didn't want to be the academic software engineer who was brought onto the project, and then I didn't follow procedures and I introduced major bugs, and then basically be the subject of a newspaper hate campaign going, look, even proper research software engineers in academia are going to do stuff and create rubbish, useless code and don't know how they should be coding things, because that would risk my reputation and that of the wider RSE community. But more importantly, if I did things in MetaWards that slowed them down, caused delay, made the wrong answers, then potentially it could lead to the wrong advice being given. So the wrong decisions would be made, which would then have real life or death outcomes. Obviously, at the moment, I feel less concerned about that because government is not following advice. So fun. So basically my driver, particularly in middle of March onwards, was I was going to follow all of the procedures, take everything I knew from like 20 odd years of doing software engineering and follow everything to make sure that effectively MetaWards was not just a well-engineered code, but it was also an exemplar for how far academic software engineering has come over the last 20 years. And it kind of resulted in this. Sort of the website, you can see there all the features in it. This basically captures everything that MetaWards now has, but also exactly how it's been designed and it's been run. So you'll find everything here: developer documentation, user documentation, tutorials, roadmaps, all of the release notes, how do you get into the community, codes of conduct, pretty much everything you could think of, all wrapped up with GitHub, CI/CD, everything automatically being built, versioned website, etc. Obviously, all of it's completely open source. So if you have any interest or any questions of how do you get to do this in a project, so how do you get a version website, how do you set up GitHub Actions, how do you build a pip package which works on any Linux, Mac or Windows, please feel free to get into touch or just take a look at the code that's on the website. Now, one of the things that came out of MetaWards is through the last few years, we obviously follow procedures for coding. So we were doing documentation-led development and effectively test-driven development. And what we've been kind of evolving is something we're now calling tutorial-driven development. And I believe lots of people now do tutorial-driven development, so we're not claiming to have invented it. But tutorial-driven development we found to be a really useful process for developing software when you're working with a research group. So when you're developing software on your own, your driver, the motivation for the software is, I'm going to write software today that solves my problem today. And because I'm the one using it, I don't need to tell anybody else how to use it. But when you're working as an RSE on a project, you're not developing the software for yourself. You're developing the software for somebody else, which means you have to tell them how to use that software. So traditional methods where you're doing like test-driven development, or you're writing documentation-driven development where you're doing sort of developer docs, those methods tend not to concentrate on how you're going to tell the users how they're going to use the software. And so you end up with a gap between what the users think and what you're doing. So what we kind of evolved to is doing tutorial-led development, where effectively the primary output of the software engineering process is the tutorial, which teaches people how to make best use of the software. So the aim is not to write the software. The aim is to write the tutorial that uses the software. The secondary output is then the software that actually does what it says it will do in the tutorial and implements that functionality. And then the tertiary outputs are the unit testing suite that validates the software is working correctly, plus then your developer level documentation so that you can then onboard new developers and they can then create new tutorials for new features. But this is really a user-focused development system. So as I said, writing the tutorial is the driver for writing the code, as opposed to I write the code, then I write the tutorial later. We can make this even stricter, because if the user doesn't know how to use something in the software, that means that they don't know that thing exists and it's completely useless. So actually we can take a much stronger line that if it's not described in the tutorial, it doesn't exist. So the software will only do what is described in the tutorial. So why do we do this? Well, we kind of evolved it in previous projects where we were developing software and then writing tutorials with the software, and then the things kind of overlapped. We did it this time because it was very clear when I started the MetaWards project that I was going to have to take the code away from them. So I had to quickly get to a position of trust where I could say to Leon, your C code is good, it does the right thing, but look at this Python code, it's going to make your life much easier, but I'm going to have to be the one developing it now. I'm really sorry. And there are lots of reasons why. Again, go in the blog to see why I was able to justify this, and Leon's now very happy. But it was introducing a new programming language for them, a new way of working in terms of how they're actually developing software, but also we reproduced the original C code in about 2 weeks. But the main reason for doing this is because we had to add lots of new features to the software to model things like how lockdown was progressing, hospital admissions, ICU admissions, holidaying, lots of bits and pieces. And there was no way that the C code could have those things in it. So we had to implement these new things in the Python code. And that meant I had to have a way of communicating to the epidemiologists how they were going to use those new features. So because we had to do the communication, the tutorial was the major thing that we needed to produce. And as I re-emphasize here, anything that I write in my code that they don't know how to use or they don't know exists is a waste of all of our time. We were under massive time pressures. So there's no point me writing a brand new feature and then expecting them to read the source code to learn how to use it. There must be a tutorial for it first so that it exists and we're not wasting each other's time. As I said, time's critical. So porting and optimization took 2 weeks. So March 23rd was when we first got involved. We had in Python by the end of March, and then everything we produced and working quickly, I think first week of April. And then we've been working on a fortnightly schedule roughly for adding new features. It's quite scary when I look at the release log and see actually how quickly things were going. Fortunately, it's slowed down a bit now because things are more stable. The other reason we did tutorial-led development was because the epidemiologists needed to use the new code immediately. So they needed to see what was coming, learn how they were going to use it, and then as soon as the code was gold, be able to use it without having to sort of email me and go, how do I use this? How do I sort this out? This isn't working, blah, 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 blah. Because, you know, it would be a very bad idea to make me a bottleneck in the system. You know, say, for example, I caught the virus again, I could be wiped out. So that would not be a good thing. So the tutorial, again, for communication, for making sure you get rid of bus factors was really, really critical. An example of this, I'm going to take you through the process of tutorial-led development. So step 1 of the process is you basically agree on the new feature with who you want to be developing. And normally this would be done via like a short meeting. So with Leon, I think since March, we've probably had maybe 1.5 hours of meetings in total over this period. So you have these very, very intense, but very information dense meetings which can be called off because they get pulled to government or whatever, which are very kind of like, we have to communicate things very quickly. So you have these things where you basically go, we would like to model X. In this case, they would like to model the movement of people between home, shielded, people who work in hospitals, patients, and then moving into the ICU. You have a sort of a whiteboarding of how could we do this in the code using the features that we have already, but developing some new ideas and what new software is needed to sort of make this totally work. So you end up drawing pictures like this. So these models work by people start as being susceptible and then they'll move horizontally through stages like latent infection, mildly infectious, very infectious, and then removed from the population. And so we're ending up drawing things like, okay, let's now add in the ability to have not just horizontal movement between stages of the disease, but also vertical movement. So people who are quite ill can now move to become patients, and some of our patients can move to become ICU patients, etc. So we agree on this design. We put a straw horse sort of thing up that says how it would kind of work. And then once we're agreed on that, which is normally sort of one meeting, I then basically then create a feature branch in the repo, which is going to be for this new feature that's necessary. The first step in creating the feature branch is I write immediately the tutorial page for this feature. So the tutorial progresses linearly. So you do need to have done parts 1 to 6 before you can do part 7. And part 7 was basically this using different pathways to model different demographics, because we call those vertical movements different demographics, because they evolved out of code for modeling different ages, even though demographic now we're very much overloading that term. So create the feature branch, write the overview page first, which says this is roughly what the feature will do, like learn how to give different disease pathways, different demographics, explore how it can be used to model different disease behaviors, see how this can be combined with move functions to model conditional pathways, i.e. people going to hospital. And then once I've created this initial tutorial page, the next step is to write the first page of the tutorial. So there's no code at the moment. I'm now writing the tutorial of this is how you would model it using the code. So you keep going, using as much as possible that already exists. And once you kind of hit the point in the tutorial where the code no longer does, the feature, there's missing code now, it can't do what you want it to do, just keep going a little bit further and just write more of the tutorial, because actually the process of writing how the code should work, using as much as possible that exists already, really focuses your mind onto what new functionality needs to be added to let the rest of this page work. Once you finish the page, you then actually write the code. So you go into the software, you write the code that's needed to actually implement what is available in the tutorial, and you keep using the tutorial to run through that new feature that you've added. So you make sure the tutorial, you finished because the tutorial now works. And then because you don't just trust, oh, the tutorial worked, you also in the process use your normal unit testing and runtime tests and developer docs, etc., so that then you can validate that everything you're adding is doing what it should be doing. So effectively, the tutorial is almost like your integration test, and your unit tests are basically testing all the little bits of functionality that you're adding in at the bottom to make things work. Finally, step 6, you then test that the code gives the outputs you expect for the tutorial, and now you've got the outputs, you can then copy those outputs in as the pictures or the animations, which then go into the tutorial as the example that the person should be able to reproduce. And indeed, doing that, that focused me on actually making the outputs way clearer and easier to follow, so that then the tutorial was easier to write. And I even ended up writing a small tool called MetaWards Plot, which very rapidly would generate animations and pictures to make the tutorial easier, but also it made the epidemiologists' lives easier as well. This is kind of the overall picture. So that would be for one feature that you're doing. So one chapter in the tutorial, create the feature branch, create the tutorial chapter and overview page, write a section, write the code, write the tests, generate output. And then you keep going around writing each section of the tutorial in this kind of cycle here until eventually you finish the tutorial chapter. And yes, now the code is doing exactly what you want. You then push everything from that feature branch into Devel. That will auto rebuild the website, auto build your packages, auto build everything you need. You can then basically give that to your testers to do greater integration tests. Maybe you need to then do more features because maybe there are more features in this particular release before we actually get to the end. But once you've finished implementing all the features, you then push the whole lot to master. It will be renamed to main. Test it, integration test it, tag it, and then everything is then automatically rebuilt to then have the website tutorial and all the binaries, and everybody's happy, and then I move on to the next 2 weeks of work. Now, one of the things that came out of this is that if you're doing tutorial-led development, you really need to have a versioned website. So if you had just one version of the website, so the website was always showing the latest version of the code or the latest development version of the code, what would happen is that the people who are following your tutorial would always be saying, this doesn't work because it's not implemented or it's in a slightly different way. So what you have to have is basically have every version of your code available on the website so that the tutorial matches the version that the person is using. And the way I set this up is basically have the latest version of the code. So the last release is the default. Development is the latest dev release. And then obviously you can see all of the previous versions then have all of their links. And then there's some automatic code when I generate the tutorial pages, which basically says this tutorial is suitable for versions 1.1 and above. If you're using a lower version, then please can you upgrade? The tutorial also forms part, now that we've moved into 1.0, so we're using Simver, so we're basically actually using backwards compatibility guarantees. The tutorial forms part of the backwards compatibility guarantee. So this means that the tutorials written from 1.0 onwards will work for versions 1.1, 1.2, etc. going into the future. Again, just making it easier for people to find the right tutorial and move forwards. Now, one of the questions I got when I first talked about this was people going, oh, aren't you in a rush? Isn't this like the slowest way to develop code ever? Like, this must be really slow and like, you know, just write the code, it's much faster. And what I would say is actually the MetaWards is the most professional program that I've ever developed. And it's also been the fastest to write. As I said, we're on kind of a 2-week release cycle. You can go through the changelog and see how quickly things have been coming out. And it's really shocked me how quickly tutorial-led development has actually made me write code. When I sit down to write the new bit, the new feature, because I've written the tutorial first, my focus is totally on just the bits of the code I need to make the tutorial work. So I'm only ever writing useful and relevant code. Every bit of code has to have a purpose. It has to actually go to, you know, satisfy the feature I'm working on. I'm crystal clear at every single time I sit down. I can just read through the tutorial as to where I'm up to, and immediately my head is back in that sort of mind space of being, I now need to write this bit. It's stopped me going down so many rabbit holes. So sometimes when I'm writing code, I can think of, oh, I would like to re-architecture this bit, or I'd like to redo this, or I should make this new feature because it could potentially be useful later on. All of those are like rabbit holes which aren't producing useful software today. And so the focus is not on let's build complicated frameworks underneath. It's build useful software today that satisfies today's tutorial need. It's caught a ridiculous number of bugs. So even when I've got unit testing in place, people running the tutorials are the best distributed CI service that I've ever had. So basically, they run it on every single operating system. They mistype things when they're putting things in, when they're going through the tutorial. They obviously use the tutorial and expand it for their own application. And that basically finds loads of bugs and on loads of operating systems. And basically, one of the people using it was a Windows user. And he wrote new bits in the tutorial so that we could adapt everything for Windows. And he pointed out all the issues on Windows and became my Windows tester. And now we have a beautifully working Windows version. And actually, we know now that this software works beautifully on pretty much every operating system, x86 and ARM64. What was interesting is the bugs that we found, the most evil bugs, the most evil bug actually in this was there was a bug with the Windows threading system that meant that even though on every single other operating system, we're very careful that all of our threading, it's all OpenMP, it's all deterministic. So with the same random number seed, same number of threads, you get the same answer. But what we found on Windows was there was this weird error in the threading that basically meant that the reduction was not happening properly. So there was basically a sum over all of the wards and it was giving the wrong answer. Now, we knew it was the wrong answer because I have runtime testing built into the code, and we actually calculate things in different ways and then compare those. And if we get a different disagreement, we know that the code must be wrong. So there's loads and loads of layers of checks. This is what I mean by a blast radius. So threading problem causes a difference in counts. Those difference in counts blows up that part of the code, but we have a check which then limits the blast radius and then basically prints an error out and goes, look, on Windows, it doesn't give the right answer. Now, if we didn't have that, on Windows, the graph would have looked right. And it would have been a perfectly good looking graph. You would never have spotted it. They wouldn't have known that they were getting a completely different answer to me, which was the wrong answer because they were not summing things correctly. And it was only through having people run it on Windows using a tutorial that this, and having runtime testing, that this was caught and basically sorted out. This also provided the best medium of communication with users because it meant that effectively I could say to the user who was coming onto it, anyone who wanted to be a new developer or anyone who was a new user, go and read the tutorial first, work your way through it. And then when they had a problem, they were like, I have a problem on chapter 6, part 1. We're immediately in the same space. And we could debug that, or they could ask, oh, I want to add database support to part 3. How can I add database support to part 3? And it just gave us a common grounding for our communication. A good example of this, and I said, because the epidemiologists could see the tutorial advancing step by step in Devel, it meant that they were ready as soon as it became gold. So this was last week where we basically got chapter 7 finally published as 1.1. I'd published the final beta to Devel on Tuesday night. All of this that you see on the screen is what one of the epidemiologists developed on Tuesday night. And they basically worked out how they would use it for their model. They worked out their parameters. They then built their disease files that they needed. I published 1.1 gold on Wednesday, and they'd already then were running it, using it by Wednesday night and generating interesting results. So again, it just speeds up that whole transfer of information, knowledge transfer to your users if you're tutorial focused. And they weren't just writing like data files. MetaWards implements a plugin system, so it's an extremely flexible program to enable you to do any type of modeling you really want for diseases, but it's implemented using Python plugins. Now, I remember when I started, I had people going to me, you're making them use Python, they're our users, please don't make them use Python, they'll be terrified of it and they'll hate you. To which I was saying, no, Python is not that bad, and I will give them big carrots. I will show them how wonderful the world of Python could be. And through the tutorials, they learned Python. And indeed, the Python they're now writing, so these two plugins that you see here, Move Pathways and Mix Pathways, those were written on Wednesday last week by the person who'd gone through the tutorial to model diseases. So you can see here, this is the hospital, so people going from the general population to asymptomatic super spreaders, and then asymptomatic to general population, then general population to hospital. Notice, beautifully written functions. They've added in some documentation. They're using advanced features of Python, so these are Lambda expressions. They're explaining what they're doing as they go through, and they've done this because they're following the style that I'd set in the tutorial. So I'd had so many example plugins, they were basically copying and pasting those, and they were learning what they needed to learn from the plugins and from the tutorial. And from this, they've seen the wonder of Python, and they really like Python. Actually, it's sort of quite nice. It's sort of beginning to change culture in a community. So the tutorials provided a meeting place between the RSE, so myself and the other RSEs in my group and the users. It defined a common language, both for communication and for the style of coding. And it also provided a way for them to ask for features and for me to basically find out what they needed. So basically they would do a tutorial and then they go, oh, I really want database support. And they'd post an issue for database support. Or I want a different way of accumulating data. So you're currently doing SEIR, but I want H as well. How can we do that? And these then got turned into new feature requests, which became feature branches, which would then be tied into new feature milestone releases. And as I said, all of these things then got turned into new chapters, or sometimes additions to old chapters. So for example, the database support, that became a new page in the output chapter, so that I could then say, look, this is how you now write to databases. And then if you're going to do that, if you're changing the tutorial retrospectively, so you're adding older chapters in, or older sections to older chapters in, that's where your changelog becomes important. So with every single changelog, we now actually post in the changelog the links to the tutorial pages, which are the new features which have been added, so that our existing users can go, ah, this is how I find out how to use database support or the other things. As well as doing this, you need loads of other stuff that's really useful. So I have a well-planned roadmap, which is on the website. The roadmap basically takes all of the features we're planning to do and just groups them together. So you can see we're currently going towards MetaWards 1.2 to model holidays and age-related behavior. We use GitHub issue tracking a lot, but I basically put a screen on the issues. So when you try and post a new issue, you're going to have to say, is it a bug, a feature request, or other such things? And there's a template that you have to follow. And by doing this, it basically got rid of any kind of spam or people attacking us. So it's not a problem. So the roadmap plus the feature branches and what I'm working on, it lets the epidemiologists know what I'm working on, when it's expected, follow the development so they can prepare for when they get to that point. Roadmap is then tied into the milestones. So again, GitHub does this great thing with milestones, so I can tell people roughly when they should be expecting to see these releases, etc. And really to show that this was appreciated, I actually had a nice email from one of the epidemiologists who sort of relayed some of Leon's words, and he was basically saying that, they think it's fantastic, but the main things they liked were keeping the documentation up to date with the different versions of the code. That knowledge transfer is really good. They think that the involvement of RSEs is great. So it's great that people like us, RSEs, can offer the expertise and time to these kinds of projects. And I think the thing which I really wanted is that we don't swoop into a project, do the work, and then swoop out again. What we're meant to be doing is that meeting of cultures. So just as I've now learned a lot of epidemiology and more than I really want to know now, given what the winter is going to look like, and my depressing start to the day, that community has now actually learned a lot of good software engineering practice. They've learned Python, and as they've said here, they enjoy learning how to do things better, how to pick up areas of good practice. And I think that's really what we do. We communicate. We're not in a bubble working separately. We come in and we form part of that research team. So I'm just going to acknowledge, the MetaWards and the UQ teams that are working in my group. The RSE Fellowship was so important, and I am telling EPSRC this, that the RSE Fellowship is so important because it meant that I was a knowledge and person capability of the UK. So I don't have to justify to anyone other than EPSRC what I'm doing with my time. So effectively I could say they needed help. Can I work with them? Yes, life is good. I now need to tell a manager or something that I'm going to do this. And I think it's really important in the UK that as well as having a hardware capability, that we have these people and knowledge capabilities that can then basically be deployed in emergencies to sort of help. GitHub is awesome, Python's awesome. But before I finish, I would like to do a odd one out round. Anyone who knows if I've got news for you knows how this round works. So again, you're happy to speak out if you can guess the odd one out. So we're going to start off with a photo of Japan in December 7th, a photo of Thailand on January 28th, a photo of Vietnam on February 6th, and a photo of the UK on March the 19th. So can anyone spot the odd one out? I love science. When I do teaching, silence means you all accept things and life is beautiful.
The difficult one, Chris.
It's difficult, yeah. So basically, the odd one out, the answer to this is that all of the countries have less than 1,000 recorded COVID deaths, except for the UK as of last week. You can leave it to yourselves to decide why that might be the case. There's been a really, really good. So I sit on the. I get to like see the Slack group of the epidemiologist group we're working with. This is one of the things they've highlighted, paper which basically did just an empirical analysis. So they basically plot the incidence of the infection on a log plot, and you can see changes in gradient to when events have occurred. There's one I'd love to share, which I can't, which shows a change of gradient when somebody went to Durham. I'm looking forward to that being published. But this one was basically comparing places like New York and others, where effectively it was very clear that the time when people were told to wear masks corresponds to a massive reduction in transmission of the disease. The empirical evidence for you should wear masks all the time in public is so overwhelming that I find it incongruous that this very cheap thing that would mean we wouldn't have stupid rules about who we could see and how we could go out and everything else is not being followed. And basically the reason that those masks work is because it's very clear now from the evidence that when you're infected, a lot of people either are asymptomatic or they go through a pre-symptomatic phase when they're very infectious. And because you have that phase, it means that it's really too late to wait until you have symptoms. And there's been so many cluster outbreaks. This is a cluster disease, so effectively it's like a fire. A spark goes out, and when the spark goes, it ignites a new outbreak, as we've seen in the meatpacking plant in the northwest at the moment, the China food packing plant, etc. All of these have happened because basically it's cold air. The virus does look like it's spreading in cold air, so good luck this winter. And if you wait until you're infected to wear a mask, you've already infected other people. So you should wear a mask all the time in public, inside and outside, because that's the only way we're going to be stopping the disease, in my opinion. So thank you. Any questions?
Thank you very much, Chris. That was a really wonderful presentation on what you've been doing. And obviously at a critical time, but also I think a wonderful overview of the kind of impact that research software engineering can really have. And the work you and your group have been able to do there. So any questions from the, sorry, I've got a bug in my throat.
Jonathan here, Jonathan Teds. Hi, Chris, that was a brilliant talk. My question is, you gave all sorts of evidence for how that collaboration you've been working embedded with, if you like, at some level, how they have, adapted their practice based on the learning experience through this collaboration with you and your team. But how could we track? Do you see any evidence yet for it actually going to the community? You referred to a community moving. Do you think those people will now advocate with it more widely within their own community, or does it, I'm interested in any evidence for that.
I think it diffuses. So the community of epidemiologists I work with is about 6 main leads, but they're then leading about 15 to 20 PhDs that are now using MetaWards for large runs. And so they're kind of like diffusing it down to those PhDs. So I think with all these things, it's a diffusion thing. And obviously I'm going to milk this talk for everything it's worth at the end of this year. Just basically, because I think, again, we can get the culture change from the top by talking about people who've already done it. So I have a great belief in the power of jealousy. So, hopefully as the MetaWards team are doing some really fantastic work and publishing some various great things through the summer, we'll be able to point to the RSE workers, helping them do that, and then translate that to hopefully other communities.
Yeah.
Nobody else with their hands up at the moment. And I was quite interested with something that came up in one of the blogs, and you also mentioned it today. so you've talked about not introducing features unless you needed to, unless there was the tutorial for them. But you also said that you've been able to repurpose existing functionality. And I think that's really interesting. Could you? It's always interesting, isn't it? We try and abstract so much so that we have something that's going to be truly general. So yeah, could you just sort of talk a little bit about that?
Yes. So as I said, we have to try and reuse what we can. So I can't say, okay, I've got 2 weeks or so to do the next release. I'm going to have to write a whole new framework or a whole new thing for it. So your mindset is already in that space of what can I pick up from the existing toolbox that I've got. So it's forced you when you're writing to write everything as though it's a toolbox, as though it's a little building blocks. And so that's why Python's just really good, because you make all these lovely little reusable building blocks. But then when you're writing the tutorial, because you start off writing it with everything I've used at the moment, it becomes a question of what do I now need the person to learn to be able to get this new feature. So the example of the hospitals is good because effectively we were saying, okay, we'd already put in the ability to have multiple demographics for different ages effectively. But for the hospitals, we needed the ability for the different demographics to, or for different groups to follow different pathways. So instead of going latent, infected, infected, recovered, they could go hospital infected, ICU, ICU. And so what kind of realized was actually, rather than write a whole new decision pathway that was used and a whole new way of modeling these kind of vertical movements, we have these demographics already. All we actually need to do is, instead of saying every demographic follows the same disease pathway, just make it that different demographics can have different disease pathways. And instead of calling them EIIR, let's call this pathway HHICU. And then, okay, the code can do this, but I need a small amount of change so that I can have a different number of stages for different demographics. But then we need a method of moving people vertically. Okay, the new code we need is a mover, which can move people vertically. And so by going through that process, you realize actually to implement what looked like a big change, which was conditional branching in a pathway, all you needed was small bits of code to enable you to have different numbers, and then a bit of code to enable you to have vertical movement.
Yes, I really like the way that's the repurposing. So what you say, yeah. So you have your demographics, but your demographics actually become a subset of a different hierarchy of pathways. So
yeah, I mean the biggest difficulty we've had is now the word demographics has been so overloaded in the code. Because they're not really demographics. We've had discussions of should they be called cohorts or groups, but because we have the backwards compatibility guarantee, we can't rename them. So they're now demographics, just accept it. A demographic is a group of individuals who will follow their own pathway, and you can move in and out of them.
Any other questions for Christopher?
Everyone's now basically looking at what they can short for the winter.
Yeah. Hopefully you haven't terrified everyone too much. Everybody rapidly drafting their applications for New Zealand citizenship.
Yeah.
Christopher.
That's okay. We seem to be exporting people to New Zealand to infect them, so that's fine.
Ed, did you have a question?
I did. I was just asking if you've got anything online somewhere that describes tutorial-based development.
This talk now. So I asked James if he could record it. So the talk has been on my website since last week because I managed to get some time to write it last week. I'm going to add the link to this recording as well, and then through the next, when I get some time away from working on MetaWards, I'm planning to write, I don't know, some form of paper or something just to describe it and point to some actual concrete examples of how this has helped and how it surfaced bugs and the knowledge transfer.
Thank you very much.
Question about the tutorial driven development. I'm just wondering how you enforce it. You say in the one of your slides, if it's not a new tutorial, it does not exist. Is there? Do you have any automatic tests, something like Cucumber for behavior-driven development, but on your tutorials, or do you compile your tutorials to prove that the things in it still hold?
No, that would be a good idea. So at the moment, the epidemiologists don't know it exists, they don't use it. So it's the humans have kind of said, well, they're not using stuff that they can't see. So it's kind of
that works for new features, but in terms of like old features, as you get feature rot, and something stops working, is there any way of catching that so that so no one ends up following a tutorial that's become outdated because you haven't realized that something has drifted in the code?
Yes, so the unit tests do catch those things. So they do basically validate those parts work. I do periodically rerun through all of the tutorials to regenerate output, because sometimes we do like output changes so that the outputs look slightly different. But I know it's on our, like, one of the things I'd really like to have once we have some time is to build a separate repo that contains all the tutorial data, so that then we can then just do an automatic sort of CI run through all the tutorials, regenerate all the outputs, and then bring them back so I can put them back into the tutorial. Because at the moment it's very manual having to run.
You might look for a Python equivalent of Knitr or R Markdown for the sort of Donald Knuth style literate programming, because that might help sort of close that circle a bit so that your tutorials could be executable, and you don't have to have a manual step in there where you copy the outputs in. I think there are a few that exist. They're still pretty embryonic, but it's probably enough for what you need.
Yeah, I mean, we'll take a look. And most of the things can run on a laptop because it is a very fast, very small code, but it's the larger things that then need, 256, 512 cores and take an hour. Those bits are the ones that's kind of been the question on it, and sort of like, how can we create a cut down version which can be validated in CI without then running the full version? But then we do need the full version if we're going to do an update.